Good morning, students. In today's lecture, we will explore few more things related to your database management systems. And in our previous classes, we have seen a basic introduction related to your database management system, like what is data, what is database, and how it has come out, and what is database management systems, and what are its different components, and what are the different views associated with, and all these things. Okay, how database has been designed, and all these things. In today's lecture, what we are going to do is that we are going to see the design view of your design aspect of your database. Okay, as I already told you that we have three different abstract level of designing of your database, and first it starts with your conceptual level, then it's your logical level or representational level, then we have physical levels and all these things. So we will explore one by one all these models in our lecture. Okay, and whenever we talk about a design process of a database, then there are few things that we need to remember. Okay, what are the few things? Okay, we have in the design phase of your database, we have initial phase. Okay, this initial phase characterize fully the data needs of prospective database user. Okay, in this initial phase, what happens? A normal naive user uh, suggests or speaks about his personal needs of its database. Okay, what is its requirement will be specified to a database administrator or to an engineer who is very specific, who is an expert in designing your database. Okay, so what happens is that a naive user approaches to an engineer who is expert, and that experts characterizes the need of the user. Okay, because the user never knows uh, the designing concept of your database. Okay, only the experts knows about it. So a naive user, when it approaches to an expert, so he characterizes different things that relates to its need. Okay, it happens in your first phase, and in the second phase we choose a model. Okay, it may be an ER model, it may be a relational model, whatever it is. Okay, depending upon the requirement, we are going to choose which model will be suitable. We are going to choose a model to design the database. Okay, once we uh, uh, once we choose a model, then what happens? During the choosing a model, we apply all the concepts of the chosen data model. Okay, then translate these requirements into a conceptual schema. These requirements that is being specified by the user it will be developed into a conceptual schema or high level view. Okay, of the database. Once a fully developed conceptual schema indicates the functional requirement of the enterprise, means once we collect the requirements of the naive user, then we develop a conceptual schema. This conceptual schema, what it is going to do is that it is going to give us an overall view of your database that is going to be designed, means how where exactly which components has to be placed and how they interact with each other. Everything will be placed in a proper way through your conceptual designing. Okay, then in the final phase, what happens? In the final phase, once we get the conceptual schema, then further we go to design the final phase, where we mainly focus on the logical design part of your database. Okay, moving from an abstract model that we come out of your um, conceptual schema, then we move to your logical design, deciding on the database schema. Okay, in this schema we are going to do what kind of relational database and what kind of database we are going to use over here, we are going to see in this case. Okay, in that means we mainly focus on the logical designing, deciding the database schema. Okay, database design requires that we find a good collection of relational schemas. Okay, and we also go for a in this process we we do two things. Okay, business decisions and computer science decisions. What attributes should be record in the database, it has to be decided. In computer science decisions, what relation schema should we have and how should the attributes be distributed among various relation schema. These two answers will be two questions answer will be given when we design your logical designing. Okay, then finally it comes to, once we are come out with a logical design, then finally the physical design, that deciding the physical layout of the database, how it will be stored inside your database. Okay, so all these things is normally done in case of your design phase. So first of all, we'll try to explore the first phase, that is your collecting a conceptual view design. Conceptual visual view. Okay, from this conceptual view we'll explore the logical design and a few more things in near future. Okay, whenever you talk about your conceptual view designing of your conceptual high level of your database or conceptual view of your database, there comes an the important model that is called your ER model, which is very popular, which is also known as your entity relational model. Okay, and we will explore one by one hereafter. Okay, then whenever we talk about your design process, whenever we design a database, we should not forget two things. Okay, that's what we say, the design alternatives. Whenever we design a database, we should not forget these things, right? One important fact is that redundancy. Okay, then second important part is your incompleteness. In designing database schema, we must ensure that we avoid two major pitfalls, that is your redundancy. The data should not be redundant in your schema or in your table. Okay, and second thing is that it should not be incomplete in any respect. Okay, so this has to be done, this has to be taken care when we design your database. Okay, and instead of avoiding all bad designs, what we can do is that we can choose some existing model, and we will taking that model concept, we are going to design. Like let's take an example. Okay, if some customer arrives and if he's asking for a 2 BHK, okay, to a civil engineer. Okay, so what the civil engineer is going to do, there are two options left with the civil engineer. Okay, either he is going to suggest him some model of 2 BHK to that customer, otherwise he will pick up some of the existing model that he is having and he will suggest to that person. So there are two things, there are one important thing happens over here. If the engineer suggest any new model to the customer, there is a risk that may not be acceptable to the customer. In that case, what happens, if there are some existing model and out of those models there are some model which are very popular, so what the engineer can do is that he can take one of the model of the existing model, he will suggest to that customer, and what happens, by that maybe the customer will be satisfied and your the engineer's task may be lower down. Okay, means it's effort, he doesn't have to put much effort on designing new things, but what he can do is that he can do one of the most popular model and he will suggest to the customer. By that maybe the customer satisfaction may be met. So by this what happens, what is being done is that instead of taking and going for a naive designing process, we can choose an existing model. So there are many models exist in the market, but this ER model and this relational database model, they are very popular. So so they are currently being used all over the world. Okay, and we will explore the designing process from right from the top level to the bottom level. Whenever you talk about the top level, it comes with your conceptual view designing, and we will start whenever you talk about conceptual view designing, there is one real model exists, that's what we call as a ER model. There are many approaches available in the market, but entity relationship model is quite popular. Okay, now in this entity design in design approaches, we have an entity relationship model, which is also known as your ER model. Okay, and this normalization theory is a part of your design approaches, but we will not focus on this one right now. We will focus on the ER model, and whenever you talk about the ER model, there are three things exist in case of your ER model. One is called your entity, which we have already discussed. Then we have relation, and we have an attributes. Okay, entity is a real world thing, objects, and attributes which defines the entity characteristics of your entity clearly. Okay, by selecting these attributes, we can easily identify an entity and describe the entity's characteristics with these attributes. And the relation, what it relation this suggests is that it gives an it justifies, it provides an association of relationship between different entities that is present. Okay, so so in an ER model, what happens, these are the three main things that we are going to explore and how they are contributing towards the design process of your database. Okay, in the meanwhile, whenever we talk about ER model, we are also going to see the diagrams. Okay, the pictorial representation of different things that is used in case of your ER diagram. Okay, now we'll start with our ER model. And whenever, as I already told you, that when we talk about ER model, there are three things comes to the picture. One is your entity, then next is your attribute, then next is your relation. Okay, so I will explore one by one. Now the first and the foremost is, what is entity? By book's definition, we can say that an entity is an object that exists and is distinguishable from other objects. Okay, it is unique. The entity is very unique, and it relates to your real world things. Okay, now let's take an example like, okay, a specific person, okay, or a company, or an event, a plant, whatever it is. Okay, that uniquely represent a real world thing. Okay, now what is an entity set? A set of entity is going to create an entity set. Okay, and example is set of all persons, companies, trees, and holidays, whatever it is. So this, they are going to create your entity set. Now an entity is represented by a set of attributes. Okay, whenever we represent an entity with set of attributes, that describes, that gives us a clear picture about an entity. Okay, so whenever we talk about an entity set, the attributes is the main thing that describes, that gives us the clear picture about an entity. Okay, now out of this attributes, some of the attributes play as a primary role to uniquely identify each member, each entity in the set. So this primary key is nothing but the subset of your attributes that is present in your entity set. So let us take a small example to clearly understand what exactly entity is, what is entity set, and the attributes and all those things. Let's take an example here over here. Okay, now this if you observe this one, this table, this is an entity set. Okay, this table, this is the student table, or we can say that this is student entity set. Okay, now in this entity set, what we have different attributes. What are the attributes? We have roll numbers, names, and courses. Okay, now each component present in this table is known as your entity. Like in this case, the first row, this is going to create one entity, this is second entity, this is third entity, this is fourth, and this is fifth. So this student table consisting of student entity set, or student table consisting of 5 entities. Okay, so this is where, now if you just move to another example, this is an instructor table or instructor entity set, which is consisting of 2 attributes, and it consisting of, again, this is one entity, this is second entity, this is third, this is fourth, this is fifth, and this is sixth. There are 6 entities present over here. At the same time, when we go another example of a student table or student entity set, we have also got a different entity. This is entity set, and these are what? Entities. Okay, so we have got 2 different attributes over here. So this is how we are going to differentiate an attribute. These are what we say the attribute, that is your roll number, name and courses, and this is going to define each and every entity that is present inside your entity set. Now it's very important that whenever we have an entity set or entity, and how we are going to represent in ER diagram. Okay, as I already know that ER diagram is going to give us the pictorial representation of things or a database. Okay, now as we have already discussed in our previous example, we have two different entity set. One is your instructor entity set, another one is your student entity set, and this instructor entity set has three attributes. One is ID, name and salary. The student entity set has got three attributes. One is ID, name and total credit. Okay, now we will see how this is being represented, how entity set is being represented in using your ER diagram. Entity set can be represented graphically as follows. Rectangle represent entity set. This completely is your representing your entity set. Attribute listed inside entity rectangle. These are the what attributes. This is what, if it is an entity set, this is what is an entity set. This represents your name of your entity set. This represents your attributes associated with this one. Now the third point is that underline indicates that primary key attributes. So this is your primary key attributes. Through this ID we can uniquely identify an entity that is present inside your entity set. So this is the way how exactly we are going to represent an entity set using your ER diagram. Okay, next comes your relationship sets. Relationship set or a relation it always defines the associativity or association of several entities that is present in an entity set. Okay, now so here you this just for an example, you see here we have two different entity set. Okay, this is customer and this is product, and the customers has two different attributes. One is a customer name and one is a customer number, and this is product name and product number. Then what is the relation exists between product and the customer? This relation exists in your cell. This customer, this customer sells this product, okay, or purchases this product, something like there exists a relationship between your customer and the product. This is how exactly the relationship being defined between two entity sets. Now this is, let's take an example of this one. Okay, this is a student entity, and this is entity set from this entity. This is a student entity, and this is an instructor entity, and this particular student Peltier is taking advice from Einstein. So this Einstein is having one ID and this student is having another ID. They are being associated with a relationship that is called your advice. Okay, so in mathematical we can represent that a relationship is a mathematical relation among n entities. Okay, and n should be greater than 2. At least to create a association we need to have minimum 2 entities, and it's taken from the entity set, where this is an entity set, this represents an entity set, and this which is what defines your relationship, and this is what E1 and E2 what we say is your entities. Okay, so this is how exactly we represent a relationship among different entities in your database. Now next comes till now what we have discussed what is entity. From there entity set. Okay, then we have described about what are the different attributes. Then we have discussed about the relationship set. Okay, now one thing we need to remember is that whenever we talk about the relationship set, we can have one entity inside it, or we can have more than one element inside this thing. Okay, how it is done we are going to explore in our future slides. Now example, we can take an example over here. Okay, this is your instructor and this is your student entity set. Okay, we define the relationship set advisor. There exists a relationship between this and this is your advisor. Okay, to denote the association between this instructor, student, who acts as the advisor. Okay, so for this Creek, who is the advisor? Tanaka is your advisor. For this class, there are two instructors, two advisors. Okay, Creek is an advisor for your Tanaka. Kraj is as advisor for your Shankar and Zhang, and Srinivasan is advisor for Brown. Okay, then Kim is advisor for Oi, and Singh is advisor for Savage, and Einstein is advisor for Peltier. So this is what it shows the association between different entities present in your entity set, two different entity set. Okay, so advisor is the association between these two these two entity sets. Okay, now we're going to explore the association. We are going to see the ER diagram representation of your this relation. Okay, so this is one entity set, and this is another entity set, student entity set, and this is instructor entity set, and this is your relationship between these two entity set. What is the relationship? This is your advisor. This relationship is represented using a diamond shape. This diamond shape is being used to represent your relationship between two entities. Okay. Next, again, one more thing is that an attribute can also be associated with a relationship set. Okay. Now there are different attributes we can associate it with a relationship. So if it is this is an advisor, right? This is the advisor association between this student and instructor. Okay. For instance, if you just observe this this entity set, these two entity sets and their association or the relation, we can have attributes in this one. What are the attributes? The attributes associated with this is that. Okay. Now what this signifies? That signifies, for instance, the advisor relationship set. This is a relationship set advisor between entity set instructor. This is an instructor and the student. May have the attribute that. This is a that attribute which tracks when the student started being associated with the advisor. So Tanaka has associated with Creek on 3rd May 2008. Shankar has associated with Kaz 10th June. So this way what happens, a relationship we can have a relationship sets that defines that relationship set, and it can also have a attributes. Here the attributes your date that defines on which that a particular student has been associated with a particular instructor in an organization or in an institution. Okay, so if this would be the case, then how exactly we are going to represent if a relationship set is having some attributes? So this is a relationship set advisor, and this is having an attribute that. This that is going to define. Again, this is represented using a square, and this is your association relationship in the diamond shape. We have two entity set. This is student and this is your instructor. Okay. Now this is how exactly we are going to represent in your ER diagram. Okay. Next, roles. Now each and every entity that is present in your entity set has implicitly some roles. Once we are defining an entity, it has got some implicit role. Means once an entity is being defined or written inside your entity set, that means it has got some implicit roles. That means each occurrence of entity set plays a role in the relationship. Okay, the level like this. Take for an example of this one. Okay, this is a prerequisite. Is the association. So we have two things over here. One is your course ID, and this is a prerequisite ID. Now let's suppose that this is a course, is a entity set. Okay. Now we have three different attributes, that is course ID and title and credits. Okay. Now three different attributes. Out of this is a primary key which uniquely identifies the course entity set or table. Now it has got a certain rules. What is the certain rules? Prerequisite. What is the prerequisite? Let's suppose say that there is a course. We have a course C1. Okay, but to study this course C1, we have to we have a prerequisite. Okay, that C2. To study this course C1, a student must have completed C2 or should have a basic knowledge about your C2. Then only he can prefer this C1. So this provides a role of your course ID whenever we are talking about choosing a particular course inside an organization. So the level course ID and prerequisites are called the roles associated with a particular entity set. Okay, so whenever you are defining an entity set, implicitly some roles is associated with that particular entity set. Okay, then degree of a relationship set. Then we have obviously degrees of binary. We have binary and non-binary. There are two things we need to talk about. One is binary, one is non-binary. But whenever we talk about a binary, means it involves two entity sets minimum. It is exactly two entity sets that we are going to do. So the degree is 2. The number of entity sets that participate in the relationship is going to define the degree of a relationship set. If it is 3, it is a ternary, and more this is 4 quaternary, like that it is going to move. But in a relationship set we are normally it should be binary, and it starts with it is your 2. Then the relationship between more than 2 entity sets are very rare, or most relationships are binary. Okay, and if it is binary, then it is a if there are multiple entity sets participate in a relationships, then it will be if it is 3 entity set, then ternary. If multiple means it is non-binary. They are not binary. Okay, so the degree, if it is 2, if there are 2 entity set, okay, the degree is your 2. If it is 3 entity set, the degree is your 3. 4 entity set, 4, like that it is going to move. So the degree is going to define the number of entity set that participate in the relationship set. Okay, non-binary relationship, most relationships are binary, and this is the way how exactly you are going to represent a binary and non-binary set in case of your ER diagram. Okay, this is a ternary relationship. Okay, this we have 3 entity set over here. Okay, one is called your instructor, another one is your student, another one is a project. What the relation defines? A student takes this project under the instruction of a person over here. Student takes a project from the project entity set as a project guide, and this project guide is any of the instructor that is present in the entity set. So this creates a ternary relation. Okay, student, project, and instructor, and the instructor is a project guide. One of the instructor will be acting as a project guide for a particular students. And what the project guide is going to do? The project guide is going to guide for some project that is present in this project entity set. So this creates a ternary relationship between the different entities. Okay, there are occasions when it is more convenient to represent relationship as non-binary. In this case, this is a non-binary relationship set. Now we will try to explore the complex attributes and what are the different types of attributes we have, and what are those we are going to explore one by one. Okay, there are different types of attributes. The first one is your we can say as a simple attributes or composite attributes, single valued attributes, or there are multi-valued attributes. Okay, simple means very atomic, which cannot be further reduced. Composite means a combination of these simple attributes. Okay, we'll explore some examples. Then we have a single valued, and we have a multi-valued, then we have a derived one. Single valued, multi-valued may be a phone numbers. Okay, then a domain, a set of permitted values for each attributes. We will explore what exactly simple, composite, single valued, multi-valued by taking some example. A simple attributes are atomic values which cannot which cannot be further reduced or divided further. For example, student's phone number. Okay, if you take a phone number which is of 10 digits, okay, student further you cannot divide it into any further. Mobile number cannot be further changed. Okay, now student's roll number, student ID cannot be changed further. Okay, those they are going to create your simple attributes. Okay, now what is a composite attributes? The composite attributes are made of more than one simple attributes. It is from simple attributes. For example, student's complete name. This complete name has got two parts. One is your first name and second name. This is second and this is first. Two things has been associated with this one. Okay, so this is going to create your composite attributes. Again, we can talk about an address. Okay, address will have street name and everything. That is going to create again a composite attributes. Okay, next comes your derived attributes. What is a derived attributes? These derived attributes are attributes that do not exist in the physical database. Okay, but their values are derived from the other attributes present in the database. Okay, they don't exist in the database, but whenever there is a requirement, we take the existing attributes and we derive that attributes from the existing attributes present in the database. For example, average salary. Obviously, the average salary, it never presents in your database, but to calculate the average salary, we need to go to attributes that is called your salary, and from that salary, how many persons are there, and from there we are going to calculate the average salary. This is an attribute that gives us the average salary of an organization. So this is what is the derived salary. This average salary never exists. Okay, so then again your date of birth. Date of birth, from the date of birth we can derive your age. Okay, so we have DOB for each and every employee that is present in an organization. From the date of birth we can derive an attribute that is called your age. We calculate, but there is no such existence of your age attributes in your database, but it is being derived by taking the help of existing attributes that is present in your database. Okay, next comes your single value attributes. Single value attributes contain single, for example, social security number. Okay, and this is single valued. And what is a multi-valued? Multi-value attributes may contain more than one values. For example, a person can have more than one phone number. Yes, obviously a person can have more than one email address, but a person cannot have more than one social security number. A person cannot have more than one Aadhaar number. If it is not, he is honest, he will be having only one Aadhaar number, one PAN number, and all these things. He cannot have multiple PAN ID. Okay, but a person can have multiple mobile number. Yes, it is multiple email ID, multiple bank account. Okay, all these things he can have, but he doesn't have an Aadhaar ID or a social security number or a PAN number. These are there are single value attributes. Okay, so this is what is the process of your complex different types of attributes. Okay, that is present in your database. And what is a domain? The very important part is the set of permitted values in each attributes. Okay, like suppose a name. Name is an attribute. So what are the permitted values? You can take Raz, then Akshay. Then these are the set of permitted values in this name attributes. Okay, then if we take about the months, if month is an attribute, so we can take Jan, we can take Jan, February, March, like that. These are the set of permitted values in this one. So what is a domain? From this domain we are going to choose one of the values, and that will be entered into your database. So this is what is the different attributes that we have in our database, different types of data attributes. And how exactly this can be represented using your inside your ER diagram, how these complex attributes will be represented using a ER diagram. So this is your instructor entity set. Inside instructor entity set we have ID. ID is a attribute. In this ID we are going to have a name. Okay, then first, middle name, last name. Then we have another attribute that is called your name. In that name, ID is very unique. It cannot further be reduced. Okay, so this is simple. And Name is an attribute. It is having multi-valued attribute. First name, middle name, and last name. Address is a multi-valued, where we have street address and all these things. Then we have a phone number, then date of birth and age. This is a derived one. Age is derived. Date of birth is very unique. Okay, ID is also. Date of birth can have multiple. A different person can have same date of birth. Okay, and a person can have multiple phone numbers. Okay, so this is how exactly we are going to represent the attributes using your ER diagram. Okay, now the very important part that we need to discuss about the constraint. Whenever we try to enter values inside a table, we need to first focus on that there should not be any redundant. Okay, the things we have already seen in our previous slides. Okay, so an ER enterprise schema may define certain contents to which contents of a database must conform before it is being entered into your database. It should be conform. Okay, so it should impose there are certain constraints being imposed on the database. Okay, what are this constraint may be divided into two parts. One is your called mapping cardinality, and another one is called your participant constraints. Okay, we are going to identify what exactly this mapping cardinalities and what is participant constraints. Okay, so mapping cardinality, it is based on express the number of entities to which another entity can be associated. Entities, not entity sets, to which the entity, another entity that can be associated with, that is present in some other sets in a relationship set. Okay, the most useful in describing binary, this is useful in case of a binary relationship set, and we have got different different mapping cardinality constant. One is that those are called here one to one, one to many, many to one, and many to many. We will explore one by one. Okay, the first we will start with what is exactly one to one. Do you see here, this is an example of one to one. Okay, where A is an entity set, B is an entity set. So in this case we have got four attributes. These are the entities. Okay, and they are being mapped with your entities in a B. Addresses of A is mapped with entities in B. So this is A1, this is B1, this is A1 is mapped with B1, A2 is mapped with B2, and A3 is mapped with B3. But A4 is not mapped with B, any of the things that is present in a B. So this is what happens. Some elements in A may not be mapped to any elements in the other sets. Okay, so it is not mandatory that all the elements in A should be mapped with the B. So so this is how exactly we are going to do one to one, but it should be one to one. Only one element of A should be mapped with another element of B. Okay, then you see over here there is another example of one to many relationship, where we have one element of A is mapped with multiple element of B. You see one element of A, that is A1 is mapped with your B1 and B2, A2 is mapped with B3, B4, A3 is mapped with B4, B5. So there are many, if we can write it here, many of B is mapped with one many of B entities are mapped with one element of one of A. So this many is from this side and one of this side. So one is mapped with many is mapped with one. So this is how exactly the relationship exists. Next comes your many to one, where many element of A is mapped with one elements in your B. This is your one element of A and many element. Many element means A4, A3 is mapped with B3. A1, A2 is mapped with B1. Okay. some elements in A and B may not be mapped to any elements in other sets. Okay, so this is what we have many to many, but sometimes what happens, um, you see in this example here, one of the elements is left out, so it's not necessary. It's not necessary that all the elements should be mapped. So some elements in A and B may not be mapped to any elements in other set. This is what is your one-to-one and many-to-one and many-to-many relationship exist. Next, how exactly we are going to represent these relationships using a ER diagram. Okay, you see here, we normally represent, we express the cardinality X constraints by drawing either direct line signifying 1 or an underline like this signifying many between the relationship set. So for one-to-one relationship, this is instructor entry set, this is an student entry set. So you see over here, this defines the one-to-one relationship between your instructor entry set and student entry set. They will be mapped with one-to-one. So if it is a one-to-one relationship, then it will be represented with an arrow. This is being justified over here. Okay, this is represented with an arrow. A student is associated with at most one instructor by the relationship advisor, at most one, otherwise none. A student is associated with at most one department by a student department, if it is a department like that. So this is what exactly it happens in case of your one-to-one relationship. Okay, the ER diagram representation of your one-to-one relationship. Next comes your one-to-many relationship. In case of a one-to-many relationship between instructor and a students, an instructor is associated with several students by advisor. Okay, a student is associated with at most one instructor by advisor. So this is what exactly, this is many and this is one. This testifies this is your one and this defines your many. Okay, how it is many? An instructor is associated with several students. So instructor to student is many. An instructor associated with several students. So there are many students over here who are associated with the instructor. That is why here the many students. Many is associated with the students. Now a student is associated with at most one. So here only one student is associated with one. So this is being directed at the instructor table. So this is how exactly exists the relationship, one-to-many representation of your one-to-many relationship using your ER diagram. Okay. Next comes your many-to-one relationship. Okay. In this case, only one instructor looking. If you just look into this diagram, what this indicates, only one student is indicated and many instructors are indicated. So what happens? An instructor is associated with at most one students. That means it is only one student in this case. Okay, that is why this is one-to-one. And a student is associated with several instructors. Okay, or may not be zero. So that is why there are many instructors. That is why it is your this. This is just the opposite of the previous one. Okay. Next, we have many-to-many relationship. So an instruction is associated with several number of students as an advisor or not any single students. At the same time, student is associated with several number of instructor as an advisor or not. So this is exactly represented using your ER diagram. Okay. Next comes to your total and partial participation. Total partial participation comes under another kind of relationship. That's what we say about your participation countries. This is divided into two parts. One is called total, or we say is a partial. What is the total? What is the partial? If you just see an example over here, all the elements are mapped with some elements in A. That means this B has totally participated. Where in case of your A, it is because not all elements have participated in the relationship. That's why it is a partially. this is how exactly we are going to define, okay, the cardinality of, and that is being imposed on the database. Okay, so we have seen mapping cardinality that defines one to one, many to one, many to many, okay, one to many, and participant constant like total and partial constants. Okay, so now you see here the total, how exactly it is represented. Now we will look into the matter how exactly this total participation is being used using your ER diagram. The total participation indicated by double line. Okay, every entity in the entity set participates at least one relationship in the relationship set. Okay, participation of student in advisor relation is total. Okay, every student must have an associated instructor. That means this is totally, they are all totally participating. All the elements in this entity set are going to participate one of the instructor. So here some in case of instructor entry set, some may be free, but a student must have to enroll with an instructor. That is why here the double line indicates this entity set has totally participated in this relationship, and this entity set is partially participated in this relationship. So this is what the partial participation, and this is your total participation. This is total participation, this is partial participation, this is being represented using your ER diagram. Okay, now besides all this representation, again we have another kind of representation, complex representation. How exactly this is being represented, we are going to see it. Now you see here it is being represented as L dot H. It will simply represent L double dot H. What is this L represent? This is minimum. What is H represent? This is maximum. Okay, a minimum of 1. L is, so this L and S will take different values. Okay, and what are the different values that it is going to take? We are going to see it. Okay, a minimum value of 1 indicates total participation. A maximum value of 1 indicates that the entity participates in at most one relationship, at most 1 or 0. So this is what is the condition, 1 and 0. What is this indicate? This is L is 1. L is here, L is 1 means this is the minimum value is 1. What does it indicate? The minimum value 1 indicates total participation, means the entity is completely participating in the relationship set. Okay, 0 means highest value 0. It's not necessary that all the things are going to participate in this relationship. So if I write it 1 comma 1, we'll try to take an example over here. You see an example here. Okay, now a maximum of star indicates no limit, means as many times there exists a participation in the relationship. This is take an example. Okay, here the instructor side you have seen 0 comma star. Okay, 0 at the lower end and star at the higher end, high value, and this is L and H. L, this is 1 and this is 1. Okay, it says that from this we can conclude that instructor can advise 0 students or more students. It's not necessary that an instructor can advise either 0 student, minimum 0, or many students. It can advise many number of students. Where in case of the student, this indicates that a student must have one advisor, at least one must have one advisor, and cannot have multiple advisor. This says that cannot have multiple. This one indicates have multiple advisors. So we can take a combination of 0, star, and 1 to further define the things in your database, in your relationship sets. Okay, besides your diagram and all, this 0, star, and 1 is going to give us a clear picture about the represent relationships. Okay, like the case here. Here the L is 0, lowest base is 0, highest value is many. Instead that instructor can advise either 0 students or more students. Okay, but there is a constraint over here. If it is 1 and 1, so a student must have one advisor, must have at least one advisor. Minimum value of one advisor cannot have multiple advisor. This is what exactly represented with this thing. Okay, next. Now it is very important to understand, this is what we have spoken till now. We have only spoken about cardinality in case of your binary relationship. Okay, then what in case of your ternary relationship? We are going to find it out. What happens in this case? We allow at most one arrow out of a ternary or greater degree relation to indicate a cardinality constant. Okay, now for example, an arrow from a project guide to instructor indicates each student has at most one guide. We'll just take a small example on this one. Just see this example. We have a ternary relationship. For example, we have a mobile manufacturing company. We have a another company, that mobile parts which company get from supplier. This mobile part is one table. There are three different entity set we have. One is mobile, one is part, another one is a supplier. We are going to create a ternary relationship between a mobile. This is mobile part and this is part, and there is a supplier. This for this mobile, the supplier supply a particular part for this mobile. Okay, maybe supplier, a mobile can have different parts: processor, screen guard, camera, then many things, earphone. These are the parts. A supplier may be a supplier S1 will be supplying processor and screen guard. Okay, a supplier may S2 may supply earphone and camera. So different suppliers, but what they are going to do, they are going to supply for a particular mobile. A particular mobile, let's say for mobile M1, what is required? Maybe whatever the things is required, that is being supplied by this supplier. So this is how exactly, if three different relationship exist or three different entity set exist, how exactly the ternary relation occurs and how we are going to represent in using your ER diagram. So if you have three entity set, the degree of the relationship is your 3. Okay, so we have three different entity set. Mobile, part and supplier will participate simultaneously in relationship. Because of this fact, we consider cardinality. We need to consider it is in the context of two entities simultaneously relative to the third entity. Okay, so we are going to see the example. Okay, so this is a supplier and this is a mobile and this is the part. What is the relationship exist? Supplier supplies parts to a particular mobile. Okay, so there exists a relationship between these three attributes, these three entity set. What is the relationship exist? Supplier supplies different parts to a particular mobile. Okay, now let's see an example. Say for a given instance of supplier, an instance of a part. A supplier is there and a particular part is there. Can that supplier supply that particular part for multiple models? Okay, let's suppose say a supplier. Let's suppose you talk about the part P1 is a processor. Okay, a supplier, let's suppose say S1 is a supplier. So we have different mobiles. Okay, we have got multiple mobiles. What happens? Let's suppose say we have Oppo, we have MI, we have different mobiles with us. So this supplier will supply a processor to many number of mobiles. So in this example, consider a supplier S1 that supplies processor P1 to many company, and that uses processor P1 supplied by supplier S1 to multiple models of mobiles. Okay, in that case, the cardinality of mobile relative to the supply and part is n. Why? Because there are n mobiles for which the supplier supplies the processor. That is why there are n, many. Okay. Now next, see another example. In case of supplier cardinality, we can say that, say for a given instance of mobile, one of its part can be supplied by multiple supplier. Okay, let's suppose say that, consider an example. Consider mobile M1, that is a part P1. Let's suppose P1 is the processor. It is being supplied by multiple suppliers. Okay, because a processor can be supplied by supplier S2, S1 and S3. So in that case, the cardinality supply relative to the mobile and part is many. Many means there are multiple suppliers who supplies a particular part like a processor to a particular mobile. Here it is one, here it is one, here it is many suppliers. Okay, similarly for a given instance of supplier and an instance, a mobile supplies multiple parts. Second example, consider supplier S1 supplying a part for mobile M1 like screen guard, processor, etc. So in this case what happens, here supplier is one, mobile is one, but there are different parts like screen guards, processors, cameras and everything. So here the parts are many. So we have discussed three different scenario where two different entity sets are being kept constant relative to the others. Okay, so here in the first example we have seen n with respect many things that is being present over here, like in the case of first one, supplier S1 that supplies a processor P1 to company that uses a processor P1 supplies S1. It's multiple models. Here n is your model, different model. Here the mobile model is many relations. Okay, here in this case consider a mobile M1 has a part P1. Here the supplier is suppliers are many. Here suppliers are many. Here mobiles are many. Here parts are many. So this is how exactly there exists a ternary relationship between three different entity set, and it can be represented using this ER diagram. Okay, so this is all about today's lecture. Okay, and the next lecture we are going to explore few more things about your DBMS. Okay. So just to summarize everything, whatever things we have discussed, we have started with different designing, how we are going to design a database at the conceptual level, logical level and physical level. Then we have discussed how exactly which particular model is being used in your conceptual level, like the best model is your ER diagram. And whenever you talk about the conceptual designing, there are three things that we need to consider. One is your entity, attributes, and the third one is your relationship. And entities, we have an entity set. Entity set is present consisting of entities. Okay, and we have different attributes that uniquely identifies these entities, and then this relationship justifies the association among different entities and entity set present in a database. And we have got different types of relationship. Okay, and total participation, partial participation, and we have cardinal like one-to-one, one-to-many, and all these things. Okay, this is all about today's lecture. In the next lecture we are going to explore few more things.